Let's get started. The first thing I'm going to do, I always want to look over the problem. So I want you to take a moment. I want you just to focus in on this particular problem and read it over. I'll give you a second to do that. Because if I just read it over, takes out, the meaning behind it. I want you to take a second and read it. So read it over. Okay, that's enough time. No, seriously. Take some time, read it over. No, stop. For the purposes of YouTube, I have to move forward. But I always want you to give yourself a good 15 to 20 seconds, maybe more, to read over a problem. If you're a fast reader, within 20 seconds you could probably read it over twice. If you need more time, that's okay. The process of giving yourself enough time to read over a problem twice allows you to process the information better, and that's very important. Before I even do any reading, by the way, you can always pause me and do the reading and unpause me. But before I do any reading, I always want to look. So I'm just going to write down these steps here. I'm going to look at the problem first, then I'm going to read it. And I want to read it at least 2 times. When I look at this problem, what do I see? Well, I see a visual, and I see those cubes and the squares forming sticks and blocks, and it looks very reminiscent of things that I might see in the classroom. And I want to point out, though, that normally the ones in the classroom are sticks of 10, and squares of 10 by 10, and cubes 10 by 10 by 10. This one isn't that. This one's a little different. This one has sides of 5. But I'm observing this, and I've seen this before. So I'm going to draw from that when I do my calculations. Then I want to read the problem, and I read it twice. So here it goes. The large cube in figure 1 represents 1 unit. What is the decimal representation of figure 2? I read it once. I read it. Did that make sense? Maybe it did. Maybe you read it and you totally understand where to go with this. Maybe you have to read it again. And now when we read it again, I'm going to look at the picture, think about what it means, and make sense of it. So I look at the picture, and it tells me that figure 1 represents 1 unit. Which means this shape is going to equal 1. Well, let's just say 1 whole. That's our whole there. And it's got sides of 5 by 5 by 5. So if we wanted to find out how many parts in our whole, how many little squares, we would have to multiply these out, right? 5 by 5, so each sheet would be 25, and it has a width of 5, so that would be, let's see, 5 times 5 times 5, very reminiscent of length times width times height. So we have 25 times 5, or basically we have 125 pieces in our whole. Okay, it's a little piece of calculation that I want to do. Figure 1 is made up of 125 pieces. Figure 2 is made up of another set of pieces. Now the question says, I read it again, what is the decimal representation of figure 2? Well, it's asking me a part to whole question. Because when I think about decimals, I should also be thinking about fractions, decimals, and percents. For example, if we were looking at this right here, we could write this as a fraction. What portion of this is shaded? 1 over 4. And if I asked you, what is the decimal representation of the shaded figure, you could be 0.25. And that's exactly what we're going to do now. Except when we think about our part to whole relationship, let me make sure I have enough space here. Our whole, in our part here, we know our whole is made up of 125 small little pieces. So let me write that out here. 125 small pieces. Our parts, well, that's what we're going to figure out right now. And once we get our answer, we can convert it into a decimal. Well, each one of these squares here, it's 25. It's 5 by 5, so that gets us 25 and 25. Each one of the sticks is 5, so this becomes 15. And there's just 2 extra squares, so that's just 2. So what part of the whole are we working with here? I guess we're working with 25 plus 25 is 50, plus 15 is 65, plus 2 is 67. So we got 67 squares over 125. Take a moment, think about, oh, I gotta move the screen. Oh, I gotta move the other screen. Why don't I just move the camera? So another way of thinking about this, when we think about our part-to-whole relationship, is that our whole is 125. We've got 67 parts. Now we're trying to convert this into a decimal, what the decimal representation of this is. Now, if you're doing this on the test and you're rushing out of time, you know the feeling. What do I do? And your brain starts dripping out of your ear. And your pencil, I know it's going to be computer-based, so it's going to be a totally different dynamic as far as writing down notes. But you get to this point and you're stuck. Now, you could, if you were really crazy, you could be like, 67, what's 67? 67 divided by 125. And you could start going at it that way. I don't recommend doing it that way. I think that's going to take way too long. I would first, look at the answer choices. When we look at the answer choices, because this is part of the reading that we didn't do, but we should have done, I zoom in on those answer choices just to point out very quickly, A and B are roughly a quarter, and C and D are roughly a half. So if you're really at the point where you don't have any time, if you can just determine, is this about half of figure 1, or is it about a quarter of figure 1? I think if you're just looking at this problem and you ask yourself that question, because the 2 answer choices are either a half or a quarter, I think you can pretty much come up with it's a half. Which means if you're very rushing for time, you only had 20 seconds to answer this problem, you could eliminate B and C, A and C, pardon me, A and B. That means you've saved yourself about, that means you've increased your probability of getting the correct answer by 50%. Now, let's say you know it's going to be around 50% and you come up with this fraction. Well, there's some things you can do really quickly. One, I can look at my core fraction. My core fraction is roughly 6 over 12, or 1/2. So I know it's going to be very close to 1/2. But if I wanted to even get even closer, I could round this, and this would actually become a 7. And I could round this one, and this 125 would become a 13. So now I have a fraction, 7 over 13. This is something I think is fair to do a long division. Well, let me make some, how did I do? What did I just do? What just happened? All I did was I rounded the, all I really did was round the 67 to a 70 and the 125 to 130. So I got 70 over 120 over 130. I just eliminated the zeros and I got my 7/13. Now all I'm suggesting is this is a lot easier to do, and I think a little bit more manageable to do if you're trying to get an exact answer. If I was going all the way, I was asking myself, well, how do I get to this one right here? You know, I might, at this point, you know, multiply by 5, 65, drop down to 5, drop down to 0, put in, get a 3, sorry, get a, no, I guess it is a 3. So what do we have here? Erase some of this really quickly. Again, I'm trying to move very quickly through this. That would be, what, a 42? Did I do that right? No. 39. Okay, so anyways, guess what? It's going to be around 0.53. And the answer, C, is 0.536. So we were able to solve this by A, reading through the problem, visually asking ourselves, is this approximately a quarter or a half? Looking at this right here, I think it's visual. I think you can see that this is approximately half of this. I mean, exactly a half would be 2 blocks, and I guess and just 2 sticks almost, 2 sticks and a half. So we're very close to half, just if you're looking at it visually. But if you wanted to go all the way, you could find out that the full unit is 125, and the part that we're looking at in figure 2 is 67. So this, again, the core fraction is 1/2. And if you wanted to round it to 7 over 13 and divide the 7 by the 13, you'd actually come up with an exact representation, which is approximately 0.53, or 53 hundredths. Now, I think the different strategies that I'm using are all valid and are all going to help you with getting the correct answer. What you want to do is look at this problem and practice this on your own a few times. And think about how you're combining the visual information with what the question is asking. And that means you have to go back and you've got to walk through all the steps, finding out how many parts are in our whole, finding out how many parts are in figure 2, comparing your part-whole relationship, and going through all those little calculations that I talked about, because I'm talking about it now, and that's not the same as actually going on and doing it on your own. If you would like some help with MTEL tutoring, or if you'd like to attend one of the Harvard Square MTEL Math workshops, you should go to one of the workshops. Have some fun. You'll enjoy it. The Harvard Square workshops are for teachers that are taking the general curriculum, the 53. It's also very helpful for the 47 or the 51 if you want to get review of test-taking strategies and the core math concepts. Obviously, if you know you're a teacher that's in a situation where you need a little extra help, yes, you may be in that situation if you're watching this video, then you might want to sign up for some one-to-one and do the workshop. Only because the one-to-one gives you a little bit more extra time. You can think about it over several weeks, 1 session a week, and the workshop sort of ties everything together. You may not need the one-to-one, and so you're going to be good with the workshop. But if you know that math is difficult, then I bet you're going to benefit from the one-to-one and then do a workshop or some type of combination. Okay, team, thanks a lot for listening. Send me in your comments and questions, and I hope to hear from you soon. Thank you. Have a great day. Bye-bye.
Let's dance in style, let's dance for a while. Heaven can wait, we're only watching the skies. Hoping for the best, but expecting the worst. Are you gonna drop the bomb or not?